Morning, everyone. So we're from the Rare Breed Survival Trust, and been doing a study on how sheep can be climate friendly. I've got Andrea and Tom with me, who are our conservation advisor, and I'm the chair of the RBST. I'm not Christopher Price, who was supposed to do this, but dumped it on me at the last minute. So anyway, we'll quickly go through some slides and chat about what we've done, and then we'd like lots of questions from the audience. We'll get ahead. So the UK has always been a big place for sheep, and the sheep were the main source of income for many years. And then in recent times, they've become wool has become less popular. But the country was basically built on wool. And sheep have got a bad name recently for overgrazing and the part of the climate problem and things like that. So we decided to look at, what was the issue and how we could solve it. So in the UK, we've got how many different breeds, Andrea? 83 different breeds of sheep, which, if you go anywhere else in the world, they've got like half a dozen at the most. But it's basically because the UK is very geological and ecology different from the top to the bottom, and also that sheep were kept in large numbers in lots of areas. Firstly, by the monks who used the wool, and then as things progressed, different farms had different sheep. And then in Victorian times, instead of people buying Maseratis and Bugattis, they decided to breed different breeds of sheep. So that it's a big tick in your box if you had your own breed of sheep on your country estate. So that's one of the reasons why I have lots of different sheep. The primitive sheep, which tend to be the Shetlands, Castlemilk Murits, these are Manx. They originally came from Scandinavia, and they have short tails, quite small, very small boned sheep. And then we have the long wools, which were sort of developed to produce lots and lots of wool. And that was their sole purpose, was to produce wool. They were never really eaten from meat until they were quite old, so they would keep loads and loads of wethers just to produce wool. Is it, is it jammed? Am I pressing the wrong button? Hey up. So, and then we have the hill and heath. So they're the ones that live up on the mountains. So their wool tends to be a bit coarser because they want to keep warm and keep the weather out. Um, and they're the most pop- biggest breeds in population. So the Scottish Blackface, the Cheviot, the Swaledale. There's the more of those than anything else in the country. Need to point it that way, do I? And this is a strange picture, but the modern breed started basically with Bakewell. So he went round lots and lots of different farms and picked the best sheep he could find, and actually started a breeding program. Up to then, it was very sort of ad hoc, and they didn't, they just probably let the young rams run with their ewes. And so Bakewell was from Leicester, so he sort of bred all the Leicester types of sheep, and he also did a lot of the down sort of sheep. So in effect, he was the start of breeding sheep for a specific reason. And then we have, if we move to the modern day, we have lots of crossbred sheep. So you're in North of England mule, your Masham, and Suffolk crosses and things like that. So although we've got lots of different breeds specific, we've also got different crosses, and then obviously some of the continental breeds have come in as well. So that's even increased the mix of breeds. So we've got a massive diversity of different breeds in the UK, which was seen as a bad thing in the fact that if you saw wool and meat as a commodity, then they were all different sizes, all different shapes, they had different styles of wool. But as we move to modern times, people want that diversity, and if you're selling a product direct to the consumer, having something different is a good plus, because you've got something that's unique, that's not in the supermarket or not at the local butchers. You've got a unique breed, and you can use that as your main selling point. Um, they all thrived in different locations, so they've adapted to their climate, their geology, their ecology. And that's another reason why we've got so many different breeds. So some breeds do well on dry, sparse land. Other breeds do well on the mountains, and other breeds do better on sort of lush pasture. So I'll pass you over to Andrea now. I was going to talk a little bit about the study that we've done.
So, with obviously with any production of livestock, there is an association with greenhouse gases. It is on. See, it is on. I'm not going to eat it. So there is an associated greenhouse gas production, and the main association with sheep obviously is the methane, nitrous oxide, and carbon dioxide. And sheep tend to get a bad reputation for being problematic environmentally, but it's not a species problem, it's a density problem. And what we want to do is we wanted to fill some of the information gap. There's so much diversity in the breeds, there's so many different habitats, and there's so much different categories of biodiversity or triple SI or farming system in the UK that there is a breed or a composite that fits all. And especially with the native breeds that are adapted for various localities, there are differences, especially in the composition of their wool, in their frame, and as John said, there are so many different variables that they're adapted to. So information for native breeds themselves, mainly the way to collect this is life cycle assessments, the carbon storage in the habitats, in the grasslands, in agroforestry. And what we wanted to go and do is see how much carbon a sheep is actually carrying around itself. So what we've done is we have harvested samples of wool from sheep up and down the country, majoritarily long wool breeds, because these breeds are the breeds which carry the highest fleece. So for instance, a Lincoln long wool, they could in theory as a shearling carry up to 14 kilos of fleece, which is a significant amount. If you've got a flock of 500 Welsh Mountains, they might only have 1.5 kilos each, but that's still a significant proportion. So what we tried to do was we harvested wool from different breeds, different flocks, in different habitats, different farming systems, all across the UK, different ages and different sexes. We even went for breeds with colour variants, we went for different colours, just to see, is there a variance and can we help fill this data gap? What we've actually found is that the breed themselves doesn't make a massive difference to how much carbon is contained in the wool, or how much nitrogen or how much hydrogen is contained in that wool. But the farming system and the way that animal is kept has a significant impact. So breeds themselves, they have their own parameters. You'd find something like the grey-faced Dartmoor, for instance, which has a very hair-like fleece. They have a lower percentage of carbon in them, but a higher percentage of hydrogen in them than something like the Leicester Longwool, who we've got sheep that have come back with over 50% carbon, and these sheep that are coming back with the highest readings are actually sheep that are kept in the most natural and the most extensive way. So what we've actually found is, okay, you might not think that a Leicester Longwool is going to be at home on the top of a hill, but this particular flock that with some of the highest readings are kept organically and extensively with minimal antibiotics, minimal antiparasitics, and the land is farmed in a regenerative manner, and they have come back as the highest quality fleeces and also the highest percentage. What we've also found is that sheep who are farmed in the way that they were traditionally adapted for, so Herdwick's gritstones, that are farmed extensively on moorland and have a varied diet, again, these have very high percentages of carbon and very high percentages of nitrogen. Coastal animals, again, and animals that have a high pasture with a high legume content, again, high nitrogen content. But very interestingly, what we found is those animals that are farmed more intensively and those that are kept for the showing scene have a higher hydrogen content, which suggests that there is excess hydrogen present in that animal's diet. So potentially it may be able to be used in the future as some form of methane producing indicator. That'll be further research. But from looking at these animals and the different variances, the weight of the animal doesn't make a massive difference. The sex of the animal, older animals have a lower quality wool, they have a lower carbon to nitrogen ratio, so we'd expect the wool fibre to be a little bit more a couple of breaks in the wool, maybe not as strong, but that indicates that those animals that are being kept in an extensive regenerative fashion have actually got a better quality product to sell on. And being able to sell those animals on with a story is one way of being able to make that money back from shearing. I mean, a lot of people do believe that wool is just a byproduct, and there's so many things that you can do with wool that they're just overlooked. The carbon storage within the fleece itself, it does vary between individuals. We took samples from an entire flock in one location that grazed the same, same pasture, same feed, different age range, but that variance could vary up to 6%. And again, it was the older animals where that sequestration and that storage was actually declining. But animals who, again, same pasture in a different site, same age range, were all within about 0.2% of each other. We have sampled some commercials and some composites, and what we did find is they do have a lower hydrogen content, but they didn't have any particular high carbon content. So none of those samples actually came in above 44%. Whereas a lot of the natives have actually come in higher, especially those extensively and regeneratively farmed animals. We've even sampled animals that have come from habitats where you wouldn't expect to find a sheep. Most of you wouldn't think, oh, we've got a salt marsh, we'll put sheep on it. They're going to get fly strike. But those animals have actually come back as very good quality wool, which suggests very good quality animal and very good quality carbon storage. We've got animals in the sampling up to 16, 17 years old, where most animals have disappeared, they've long gone, whether or not they're from a fibre flock or whether or not they're going into the food chain. They've generally long past their sell-by date, but those animals, none of them, again, had particularly high carbon storage, but they were storing plenty of hydrogen and nitrogen, which shows that those fleeces can then be used either to add soil structure, or they could be used within gardening or as basis of parts, anything like that. And it's finding those niches for those breeds and those animals that maybe you wouldn't think could be used in a climate friendly manner. Obviously farmers can do a lot to change and affect the methane and other greenhouse gases which sheep produce, and how to combat that I'm going to pass it on to Tom.
So yeah, thanks everyone. As Andrew and John said, sheep in particular can quite often get quite a bad reputation when it comes to farming in an environmental way. And there's some things that we can do in terms of the breeds we select, the management that we put in place that can help sort of mitigate these factors. So when we talk about the impact of livestock and in this case sheep farming, in relation to greenhouse gases in particular, and farming in an environmental manner, as I said, we can look at different ways, and we're going to break this down looking at diet, health, management and breeding. Some of what I'm discussing has been from the Innovation of Agriculture for Agricultural document that they produced that's reducing greenhouse gases at farm level as well. So the first thing we can think about is the diet. One thing we can talk about with the diet is the use of feed additives. So there's global research ongoing in this area. The ultimate aim of the additives is to limit the cycle in the rumen that creates methane. Currently this is either incorporated into the feed or poured on top of the feed itself. Seaweed is perhaps an example that you may have seen of this. Obviously there's challenges associated with this. I think the key one is for this to be successful, the feed companies are going to have a big say in how this is rolled out. Obviously from the farmer's perspective, what is the cost of this going to be? We all know that the cost of concentrates is continuously increasing. So obviously as soon as additives and things and the concentration is changed slightly, the likelihood is that the cost is going to increase as well. So what impact is this going to have? And obviously the use of this in feed and things isn't going to impact those that are using an extensive system. So for a lot, this wouldn't be an option. So we want to look at alternative methods that perhaps that would be more suited to and more accessible to all. Another point you can think about is through looking at the grasses and the type of grass. If you can go back, we're still on the still on diet. We haven't got that far yet. So yeah, we can look at the cellulose levels within the grasses. So reducing the amount of cellulose that is present would have a positive impact, as it would lower the amount of methane. To reduce the amount of cellulose in the diets of ruminants, we can look at increasing sort of more easy digestible starches, sugars and fats, and obviously this can be achieved by modifying the species and variety and the types of pasture that you're grazing and the mixes that you're using on your pasture. I won't go into the details of those. I'm sure there's plenty of other experts in those fields that will be trying to sell you various mixes over the next couple of days that can talk about that in more detail as well. The final point regarding feed is obviously in relation to soya, and I think we all know that the production of soya creates a substantial amount of greenhouse gas emissions, and obviously this is one of the main components of a lot of the livestock feeds. So by looking at the alternatives, perhaps the use of rape meal and things, or even looking at the different farming system you're implementing, can obviously reduce the dependency on soya. So rather than having a system focusing on the use of concentrates, perhaps we can then look at more of a forage-based system. This is where the management of your grazing is critical, and also, as well as obviously the land management, we can look at the type of breeds that we're selecting as well. So some of our breeds, in particular our native breeds, have grown up with the ability to convert the forage very efficiently, so obviously without the need of inputs, additional inputs such as concentrate feeds. That's something obviously we can consider as well when we're looking at our management and how we manage the land as well. So the next topic relates to the health of the livestock. Obviously, healthy livestock is often discussed in terms of the economic productivity. But obviously this also has a significant impact on the amount of greenhouse gases that are produced as well on your farm. So by improving the health of your flock, obviously the animals are going to be operating at maximum efficiency. This can obviously help with the productive side, so the ewes are producing as many lambs as they can, they're rearing, you're reducing the mortality rates. But ultimately, the emissions from the livestock that you have will depend on various factors. Obviously, having too much disease, mortality, etc. means that you have to have more sheep to produce the same number of lambs that you're trying to achieve. Endemic diseases in particular, obviously, if they've not been discovered, can be quite destructive in terms of the impacts they have. Talking about destruction, kicking things all over the place. Obviously, in terms of the endemic diseases and the impact they can have, so obviously having less production, less produce, reducing the yield you have, resulting in poorer growth rates of your lambs as well, reducing the quality of production, and I've already touched on obviously a higher mortality rate, so through things like abortion, infertility, etc. So ultimately we want to ensure the stock we have are as healthy as possible. So stock management and the stock selection are critical to manage your stock effectively, but also operating the various biosecurity measures that we have in place. So we can look at things obviously like by health testing the flock that you have. Obviously I appreciate there can be some barriers to joining sort of formal schemes, but there's things that we can do in terms of basic health testing to understand the importance of the livestock and the health of our own livestock. So as I said, by improving the health of the animals we have, obviously it will improve the production, but also reduce the environmental impact. So by the animals operating at maximum capacity, it means ultimately we have to have less animals on the farm, reducing the amount of greenhouse gases produced, but also reducing the impact on the land as well. If we can get the farm operating as efficiently as possible with healthy animals, then the stocking rates don't have to be as high to achieve the same results. So healthy animals are key to a successful farming practice. So in terms of management, obviously this links to my two previous points about improving the pasture and the health of your livestock as well. And ultimately the type of farming system that you implement and the breed you decide to select going forward. We can also look, when we've briefly talked about the grassland management, but we can also look at the use of legumes as well on the pasture. So obviously it's well documented the nitrogen fixing properties of the legumes help to facilitate a reduction in greenhouse gas emissions, and obviously it means there's a reduced need for artificial fertilizer as well. So the legumes obviously have the ability to fix the nitrogen, but obviously having them present in the pasture as well also raises the protein levels, which can be a positive depending on what your outcomes and what you're trying to achieve as well. Obviously when you're looking at your flock and the system used, that will impact the amount of greenhouse gases that you produce as well. For example, our native breeds attributes allow them to be used in an outdoor system. Obviously with this it removes the need for housing, reducing the amount of manure produced, and obviously the issues related around methane from the muck and slurry stores as well. So obviously if an outdoor system is used, we can reduce the impact on the land by selecting the appropriate breeds as well. So some of our native breeds obviously are smaller in size, reducing the soil compaction of the land, the risk of poaching of the soil as well. So even for the most sensitive areas, there are ways in which we can utilize the diverse nature of the breeds we have in this country to our benefit as well. So then we move on to the breeding of the livestock. And obviously by improving the genetics of the livestock and using selective breeding, we can reduce the amount of methane that's produced by maximising the commercial strength of that animal. And we can obviously do that within the various breeds as well, maximise the productivity and the commercial attributes of each of the breeds. Obviously by selecting the more prolific breeders, looking at traits such as growth rates, longevity, food conversion ratio, all the positive traits that we're looking to try and promote and try and make sure our animals are operating as efficiently as possible. Obviously, historically, there perhaps has been an opinion that obviously bigger is better, so we're pushing for faster growth rates, heavy to get heavy weights as quickly as possible. I think we sort of know that isn't necessarily the case, and we need to look at perhaps alternatives in which we can try and achieve our outcomes. I think, for example, if you think about the environmental impact, and when we're looking at different breeds and things, obviously a smaller animal is going to naturally produce less methane, obviously due to the smaller rumens of the individual animal, but still have the ability to produce a lamb suitable for commercial production. So we can break it right down to the environmental impact of that individual animal. I think across the industry we're often quite guilty of grouping all of the animals together, so a sheep's a sheep, a cow's a cow. I think we all know that isn't the case, with a great deal of diversity in terms of the size of the animals. Obviously the impact that's going to have in terms of the emissions produced and the impact on the land is going to vary considerably, and that's an area, as well as obviously the work that Andrea's talked about, looking at the environmental impact of the various breeds is something that we're trying to expand on and increase as much knowledge on as well. So obviously looking at how the different species impact the land, but also how the individual breeds and the impacts they might have. So we're looking at the environmental impacts, and that's work that we're continuing to undertake now. Obviously in terms of breeding and data, there are formal schemes that you can be involved with to collect data, but I appreciate that's not always achievable for everyone. So there's simple things we can do in terms of our management to try and improve the animals we have and make sure we're selecting the most productive. So obviously simple things by looking at the birth weights, growth rates, looking for the maternal instincts, so selecting those animals that have the best mothering ability, that have been prolific breeders within the flock for a long period of time. Obviously there are traits that we want to aim for when we're looking at selecting the various breeding stock. Obviously the genetic improvement of the various breeds is obviously what work that we try and contribute to, but also relies on the breed societies and the individual breeders to maximise the potential of each of the individual breeds. As I've already touched on it, and John mentioned previously, obviously we're extremely fortunate to have such a diverse range of native breeds in the UK. And we can use this to our advantage, as I've already said. So trying to select the right breed for the system that we want to implement. I think we need to sort of move away from the focus on growth rates and trying to, not growth rates, the large animals as quickly as possible. Obviously, I think we need to think about the other impacts, as I already touched on, the environmental impacts that we have on the lands, and also think about the other benefits that we can gain from using these certain breeds. So obviously by reducing the stocking densities, looking at a forage-based system, there's other benefits in terms of the conservation grazing attributes, the management of the land, obviously through the actual grazing, browsing process, the impact to the soil, creating in some cases where we want to create bare patches. So I think all of this needs to link together, not just about obviously our commercial production in terms of, in this case, land production, but also how that fits into our bigger management plan of the land as well. So yeah, I think we're open to any questions.
I just had a basic question on the data. You were measuring carbon content of wool. Can you tell me the top and the bottom and the kind of spread there of percentage?
So the bottom result that we actually got was 36.6. That was from a 14-year-old animal who is kept extensively, but being fairly old, and the notes that went along with that animal was reduced dentition. She obviously isn't processing her feed as well as she would do, so she's not storing as much carbon. She also had fairly low readings for nitrogen and hydrogen as well, so her quality of fleece wasn't particularly good. I'd assume that that animal being fairly elderly and having reduced teeth would likely not be in the best condition at the moment. The best result that we had was a 14-month-old ewe lamb, and she was a Leicester Longwool. She was from the top of a hill in Wales, and she was 52.5 for carbon, and I think she was around 15 for nitrogen. I can't remember her hydrogen content.
Can you tell me the variation in a cohort then? So rather than a really old ewe on one farm and a good ewe on the other one?
So generally, if I take for a breed, the variation between a breed can be around 4%. But it very much does depend on how they're kept and the management system and the habitat they're grazing. So the environment they're in has a lot to do with what they're storing carbon-wise, which is brilliant that we've, there's now the data there, which now shows that yes, the environment that you keep the animal in does impact the animal, not just in its well-being and in the quality of the produce, but actually in its environmental benefits. For instance, we've tested quite a few primitives that are on some very coarse land that isn't particularly nutritious, and all of those came back within 2% of each other, all on very similar habitats. And we found the same where they've been on meadowland, in 3 or 4 different locations in the country, that a similar habitat is generating a similar storage for the same breed. Most of the breed averages, once you've taken out everything, tend to be between the 46% and the 48%. The only breed so far that's come back where colour affector has been the Leicester long wool. With the Wensleydale, they've come back fairly the same. Again, with the North Ronalds's, they've come back fairly the same. So the pigment isn't particularly affecting things.
Thank you very much. It was really, really fascinating. Thank you very much. I just had a quick question about the carbon kind of storage again. For like a layman and sake of comparison, how does that look compared to, say, a mature tree? You know, a flock of sheep. I mean, how many sheep would it take to achieve the carbon sink credentials of a mature tree or some other sort of benchmark?
Unless the sheep's wool goes off and goes into a garment and is then used in a garment or a carpet, then technically you couldn't really say it's sequestered, it's only stored. But if it goes off into a garment, it depends how many garments, how long that garment has a lifespan for. It's one of those where you'd then have to take into account the processing of that wool. So I couldn't actually give you a specific answer because it would depend on the type of wool, the length of the staple. You know, has it gone to be processed quite dirty? Is it going to be dyed, or is it going to be used naturally? And what it's going to go into.
So what was the baseline you used for your life cycle assessment for these then? What was your sort of assumptions?
We haven't done a life cycle assessment on each of these particular breeds. What we've done is we've taken those samples of those sheep from recording the habitats, the age, the sex, the life stage, any notable incidents in that sheep's life for that shearing cycle, rather than doing an entire life cycle assessment.
Okay, thank you.
You could say the same about a tree. You know, once if it's processed, then you know you add lots of different costs. So the thing with the sheep is that obviously because you're shearing it every year, that 40% is coming off every year. Well, 40 to 50%. And as Andrea said, if it goes into a garment or you know some sort of house insulation or whatever, that is stored. If it goes back in the land, then it's just cycling the carbon. But whatever you do, don't burn your wool, because obviously that carbon's going straight up in the air then.
Hi there. I was just wondering, what for wool shedding sheep, where do they sit in the mix?
So we have had some samples from some Wiltshires. They haven't come back yet, but going by the samples that we've had that have had hair sheep crosses in them, they are slightly lower in the early 40s, but then you'd expect that because that wool hasn't been on that animal as long. Potentially if we sampled some lambs, we have had high results from other breeds where the lambs have been under 9 months and haven't hit the age where the Wiltshires or the Easy Cares or whichever composite have started shedding. But because it's a shorter staple and because it's not on the sheep as long, I think to get an accurate sample we might have to actually take a hair sample as well as a wool sample. But if you want to leave some contact details, I'm happy to forward on the Wiltshire samples afterwards.
Thank you.
Very basic. You mentioned one point was about breaks in the wool. So what is the comparison with blade shearing versus clipper? Because my understanding is that blade shearing generally leaves a sort of thicker layer and therefore minimises the break.
Yeah, so if you blade shear, you leave more on usually than you would with you know a machine. But the breaks are often, so if a sheep goes through a period of low nutrition, the first thing it switches off is wool production, because it can survive without producing wool, but it can't survive without the rest of its organs working. So that'll form a break in the wool. So quite often in the spring, if you had a hard winter, you'll see lots of sheep shedding their wool because they've got a really big break in it. And sometimes it might only be a little small, so it might have only been ill for a few days, and so you'll have a little thin bit in the wool. So when that's made into garments, then obviously if there's lots of breaks in it, the wool's not very good because it doesn't bind very well. So as with the carbon thing, the younger, the healthier the sheep, the less chance there's breaks in it, and the more usable it is, really.
Hi, my question was relating to nutrition. You said earlier at the start of the talk that low cellulose diets could contribute to reducing carbon emissions. I'm not quite sure what a low cellulose diet or low cellulose species could possibly be.
Some of the research that's been done was done on animals that were grazing coarse ground as opposed to animals that were grazing improved ground, and plants that have got a woodier texture, grasses that are coarser, they have a higher cellulose content. So in theory, they would be saying to use softer browse and softer vegetation. However, a lot of the natives are such efficient forage converters that actually doesn't correspond. So again, it's research that's a lot commercial based. Nice and see John's.
Yeah. So basically, if you're grazing short, fresh grass, it'll be very low in cellulose. Whereas if you graze in long, headed grass, it'll be very high in cellulose. So in effect, that's the opposite to what most of us want to do. And also that passes through the animal really quickly. The low cellulose, so it's it's not getting the best nutrition out of it for it. So in my case, on a health, I wouldn't graze that really short, lush grass. But for low cellulose, that's what you'd want.
We touched on this before you started, the sort of controversial subject of overgrazing of sheep, and you said it sort of went back to the headage payments. But what is the incentive for a sheep farmer not to have the maximum number of sheep that the land will carry, which almost inevitably would involve overgrazing?
So as Tom said, if you have less sheep, then they cost more because you're having to put the inputs in. They're healthier because a sheep's worst enemy is another sheep. So the more sparsely you have them, the less health problems you get, less worm burden you get. So the sort of headage payments of the sort of 80s and 90s encouraged people to keep more and more sheep, and we saw a massive reduction in the amount of cattle on a lot of the uplands and pastures, because the sheep were more economical because you got a payment for every one you kept, so you bred them small and stacked them high, and that sort of habits, still there with a lot of farmers. They haven't realised that actually if you keep a few less and look after them better, then your costs will go down and you'll actually make more profit. So I think it's a bit of an education thing. A lot of the sort of conservation payments have pulled lots of sheep off the hills and out of the uplands. But it does take a long while to get that sort of biodiversity back after they've had too many sheep.
The photo on this slide's actually a sheep grazed field. So this was a very intensively farmed field 4 years ago, and it was essentially grazed to anything with mountain sheep over 5 months of the year when they came off the hill, and then fertilised and then used and cut for hay. So 4 years down the line, this is still sheep grazed, but it's low density with 3 different breeds with 3 different grazing and browsing preferences. So the combination of those 3 breeds with completely different preferences has allowed the biodiversity to return. Those animals that are on that land at the moment, they don't get any inputs. They're very rarely having to be wormed, and they are lambing at their breed averages, some of which are exceeding their breed averages. Last winter, they didn't get any additional fodder or anything because the vegetation is now so thick, despite the fact that it is continuously grazed, that those animals aren't requiring the inputs that they did when it was being intensively grazed for 5 months and then left for 7 months of the year.
Are there any sort of case study examples of the ideal stocking rate for different landscapes, again to encourage farmers to see the financial benefits of less is more, so to speak?
There are some stocking densities that have been calculated by SAC, but a lot of the stocking densities that have been calculated were calculated on the average commercial animal rather than being breed specific. So when they look at the densities, a lowland ewe would have been counted as 0.12 livestock units. But if you actually look at some of the other breeds, say if you were having to look at a Hebridean or Cheviot Cross or one of the smaller breeds, they would probably be half that. And it's it's adapting it to the weight and the breed. There are calculators out there, so the Scottish Forestry Toolkit is quite useful for helping to calculate what the carrying capacity of a habitat is without having to graze it.
Yeah, there's quite a bit of information out in various different organisations, but the Nature Friendly Farming tent has quite a bit of information about sort of lower densities and different, how that helps nature. But yeah, I think like every farm's different, every piece of land's different, and it's like finding out for yourself. But once you make that change, you wonder why you had so many sheep in the first place.
I think when it comes to the stock and density in a discussion, I can see how it's quite easy for us to sit here and say, obviously reducing your stock and density is a positive thing, and the first thing the farmer's going to say is, yes, that's great, but what's going to replace that income? And I think we obviously, as we've talked about already, is trying to explain to people that and sort of demonstrate that by obviously reducing the number of animals you've got, you shouldn't have to supplementary feed. I think we should be in a position with our systems and how we manage the land, that there should be sufficient grazing available with the growth rates that we have, that the supplementary feeding obviously taking out extreme weather conditions, but the need for supplementary feeding and additional concentrates can be removed by the effective land management, and obviously that will then lead to that replacement of income, really.
It's very much the right breed for your system as well, in the right place. Even it might be a pedigree, it might be a crossbred, but the animal that suits the land that you've got and the weather conditions and the ecology and any biodiversity goals that you've got or commercial goals that you've got. And it might be thinking of, you've reduced stock, but are you going to have to market something additional value yourself rather than say send it to the wool board? Or I know of a lady, for instance, at the moment in Yorkshire who's actually started milking her hill sheep to make soap because she's reduced her stocking density after being asked to do so by the national park, and in order to actually make the profit margin, she's actually exceeding it now. She's actually started milking hill sheep, and sometimes it's looking at something that might seem quite random but is actually, because it's so niche, it'll make you a lot more money than maybe just producing the lamb would.
Yeah, as I said earlier, having something that's local and different to the norm does help, and so like you have to keep less of them to make the same amount of money. If you've got something that's the same as everybody else's, then you haven't got a unique selling point.
Yeah, touching on that with what John said, obviously our native breeds, each of them have their own unique story, and obviously a historical history background as well. So linking that, obviously marketing the produce correctly, the way in which we're rearing the land, I think rearing the lamb, obviously we all know, improves the quality of the produce as well. So having those routes to market is critical as well, and something that we try and work on with the farmers as well.
Thanks, that was really interesting. You might not be able to answer this if you haven't done life cycle assessment, but assuming the carbon in the fleece is sequestered, to what extent would that offset the carbon footprint from the methane, the nitrous oxide, etc., from a sheep? Do you have even any sort of vague idea of what sort of impact it might have?
So we are currently waiting for an analysis from a university that will hopefully give us an indication of that, because they are hoping to potentially take some further research from it. Happy to take contact details, and once we get it, happy to pass it on. But they are looking at it.
Thank you very much, everybody, and thanks for the great questions. And if you have any more questions, the RBST tents just as you go through into the next field, right back. And we have some sheep there, shedding sheep, in fact. They're not shedding sheep.
Ignore John. They're white-faced woodlands. They're not shedding sheep. They're hill sheep.
I thought they were Wiltshires.
No, they're white-faced woodlands. They're not Wiltshires. If you do want to see some shedding sheep, there's probably some Nexlanas or something here somewhere.